In this video, I will discuss about how to analyze a non-rectangular section. In my previous video, I discussed about how to analyze a rectangular section, and rather that I will discuss about how to analyze a non-rectangular section in this video. Okay, this is the section I selected. This is just like a trapezium with the top width is 300 millimeters and the bottom one is 150 millimeters. The effective depth is 400 millimeters and the total depth is 450 millimeters, and in this section it contains two T25 bars. So the provided tensile strength or the tensile area, you can calculate it. Provided steel area equals 981.7 square millimeters. This is the provided steel area. AS. It's just only a single layer of steel at the bottom of the section, and I will take the strength of the compressive strength of the concrete is 25 newtons per square millimeter, and Fy, this is the strength of steel, as 460 newtons per square millimeters. This is also just like a rectangle section. We have to analyze this, and I use here the trial and error method, or otherwise we can use the quadratic equation method. I will use both of the methods in this video. First I will select this x means depth for the or the depth of the neutral axis, and for the compression it contributes 0.9x according to the BS 8110 part 1 book. Okay, let's take how the what is the maximum tensile force. Maximum tensile force it can be withstand by this provided reinforced steel. Okay, how we can find it? We can find it by this equation 0.87 Fy As, that is equal to 0.87 Fy equals 460 into Ax equals Ac is 981.7. We can, by using a calculator, we can take the answer is 392,876 Newton. This is the tensile force which can withstand by this provided steel at the yield point or yielded state. Okay, up to now we have think about the trapezoidal section, and it contains two T20 bars. This is the sectional details, and it can withstand this amount of 392,876 newtons by this reinforced steel. Okay, let's find for the neutral axis which can withstand the equal compressive strength. Okay, let's find. For that we can use this equation 0.45 FCU AC. Here AC means the concrete area. Here we have to find the AC is the technical or the tactic here. Let's think how we can find the AC or the area of the concrete here. This is the section we have. This is X, and we have think for 0.9x. This is 0.9x. This is 150, and this is 300, and the total overall depth is 450. The area is equal to 0.3 plus this length. How we can find this length? That is equal to, I will take this 0.3 as 3, as you can take all the values in millimeters. So I put 300 here. To find this length, we can find it by 300 minus 150 over 450 millimeters into 0.9x. This is the length of this length. This length means this length is equal to this value into 0.5 into height, that is 0.9x. To find the compressive strength, we have to solve this as 0.45 into 25 into 0.5 into 0.9x into here 600 minus 0.3x. We can further solve this equation like this using a calculator. 0.45 into 25 into 0.5 into 0.9 is equal to 5.0625x into 600 minus 0.3x. First, we can assume that x is equal to some value. I take it as 100 millimeters. So the value is 5.0625 into 100 into 600 minus 100. That is equal to 5.0625 into 100 into 600 minus 0.3 into 100. That is 288,562.5 Newton. If x is equal to 100 millimeters, the compressive strength which can stand by this concrete section is equal to this value. This is very lower than this tensile force. So the compressive, so the neutral axis is lower than this 100. Okay, let's find for x equals 140. Then the compressive strength is equal to, by using this equation, 5.0625 into 140 into 600 into 0.3 into 140 is equal, okay, by using a calculator I can get the answer. 0.3 into 140, that is 395. This is the value. Let's check with the compressive strength, sorry, with the tensile strength. Okay, this is little bit higher, so we can check for x equals 139 millimeters. Yeah, here we can take that compressive strength is equal to 392,868. This is very close to the tensile strength which can stand with the bottom reinforcement. So we can take x is equal to 139 millimeters, and we can check for the ratio between x over d, or the neutral axis over effective depth. That is equal to 139 over 400. It's equal to 0.35. That is lower than 0.5. It means our assumption, our previous assumption about that yielded state is okay. It means the reinforcement is at the yield stage. They are yielded. So our assumption is okay, it's correct. Moment of resistance, or the moment capacity of the section here. For that, before all the thing, we have to find the lever arm. Okay, what's the meaning of lever arm? Lever arm means the length or the distance between the tensile axis and the compression axis. Here we know that as there are two T25 bars, the tensile axis is lies here. So we have to find, as we know that the depth is 139, the depth is 139, as the depth is 139, we have to find for the centroid of this concrete section. If we take it as y, we can find it by, we have to think about three parts, as this is the main part, this is the second part, and this is the third part. How we can find the centroid? Centroid is equal to, this part is 150, while this one is 75, this one is 75. Centroid y into 150 into 139 plus half into 75 into 2 into 139 equals 150 over 139 over 139. This is for test part, plus I take these 2 and 3 at once. 150 over half, sorry, 150 into half into 139 into 139 over 3. It means this is the depth for this rectangular length, sorry, rectangular section, that is 139 over 3. That's the depth of the centroid of this rectangular section. Okay, here we can find, we can subject y. The answer is, we can take it as 61.8 millimeters. You can subject this y by using this equation. If you cannot understand this one, I will write it again. Just write the total area 150 into 139, that is the area of this section, and half into 150 into 139. This is the area of this rectangular parts. Here y is the centroid of the composite section, is equal to, then I will write, first I will write for 1 and then 2 and 3. For 1 it is 150 over 139 into 139 over 2. It means the centroid of this rectangular section is 139 over 2, plus 150. Here 150 means the sum of this 75 into 75 and 75 into half into 139 into 139 over 3. Here over 3 means the depth to the centroid of the rectangular section. Then we can subject y and take y as 61.8. Oh, that is from the depth top of the section, 61.8. Then we can take the lever arm as this one, this part, that is equal to 400 minus 61.8. So the lever arm is equal to, the lever arm is equal to 400 millimeters minus 61.8 millimeters, that is 338.2 millimeters. This is the lever arm of the section. Then it is very easy to find the carrying capacity or the moment capacity of the section. We can take it by tensile into Z. Z means lever arm, or the compression force into Z. I take 392,868. This is the value which we can find in the previous steps, into Z means 338 into 2. The answer is 132.8 into 10 to the power 6 Newton millimeters, or 132.8 kilonewton meters. You can find the moment of resistance or the moment capacity of the section. That is not a rectangular section, that is a trapezoidal section, and it is also just like a rectangular section. First we assume that the reinforcement is at the yield state, and by using the equilibrium methods, it means we can assume that tensile strength is equal to the compression force act on the concrete. By using that, we can find the value for x or the neutral axis. By using these values for the neutral axis, we can prove our assume, or we can prove our assumption, as the neutral axis to effective depth ratio is 0.35. As the sun is lesser than 0.5, we can prove our assumption that is correct, as the sun is yielded. And then we have to find the lever arm. To find the lever arm, first we have to find the centroid of this trapezoidal section. So I found it. This is y 61.8. Then we can find the lever arm, and finally we can find the moment of resistance or the moment capacity of the section.